got two problems up here. In both cases, we're not asked to actually evaluate an integral because I'm not giving you a formula for the integrand. In both cases, I just want to write as an iterated integral. So I want to set this up with individual limits of integration for x and for y. So I'm going to do this first for D being the unit disk, and then second of all for D being this trapezoidal region. Okay. Now, with the unit disk, I'm not really seeing four boundaries, a left and a right and a top and a bottom. That's because if I were to think in terms of the top and the bottom, they meet. And they meet again right here. So I can think of this as my left side is x equals -1. I just only have a wall here at that individual point where the top and the bottom meet. Okay. Same thing over here on the right. At x equals +1, the top and the bottom meet. And then the top would be the top half of the circle and the bottom half of the circle. Now, I could also view this the other way. I'm setting it up right now with constants for my x values. I'm setting this up as a type 1 region. I could just as easily have said that the left side is the left half of the circle and the right side is the right half of the circle, and they meet right here at a y value of 1 and down here at a y value of -1. It's so symmetric that I can set it up either way, and I'm more used to having y as a function of x than x as a function of y. So if it doesn't make a difference for other reasons, I usually let my x's be constant and my y's be my functions. Okay, so now I need to find formulas for the top and the bottom half. Well, the boundary curve for this unit disk would be x squared plus y squared equals 1. That means y squared is 1 minus x squared. That means y is plus or minus the square root of 1 minus x squared. How convenient that that gives me two different formulas for y. One of them's the top, the other's the bottom. So if I were to set this up, I find it helpful to draw in my slices. That's going to help me see that I'm not integrating from -1 to 1, even though that's the lowest value and the highest value, because within each slice, I'm just going from the bottom of the slice to the top of the slice, and that varies. That's going to be a function. So my inside integral, I'm going from -√1 minus x squared, is the y value on the bottom, to +√1 minus x squared is the y value on the top, f of xy dy, and then my x values were going from -1 to 1, and that's dx. Again, these constants just tell me where the slices start and where the slices end. Because the inside integral was finding my cross-sectional area. That's why I've got the z values in that one. Okay? The outside integral, I'm multiplying that cross-sectional area by the thickness of the slice and adding up the slices and taking the limit. Okay, excellent. I could have done this, again, by letting x be functions of y instead. In that case, you'd basically have this same thing, but all the x's and y's would just be reversed. Okay, so let's try the second problem. Now here, if I were to try to do this as a type 1 region and slice things this way, I run into a slight problem. Because I can see that over here, the top is this diagonal line. But between -2 and 2, the top is that horizontal line, and then to the right of 2, the top function is that diagonal line. My top function looks like this, and that's really in 3 separate pieces. Now, I could do this. I could actually break this region up into 3 separate integrals, and say I'm going to integrate over this triangle, and then this rectangle, and then this triangle. But that's setting myself up to do 3 integrals. So here's a time when I don't feel particularly happy about going with what usually is my first choice, slicing things vertically so that my x values are constant and my y's are functions of x. Notice if I were to slice things horizontally instead, the bottom and the top are fixed, and that one line is my left boundary, and that one line is my right boundary. So here's a great example where I really want to set this up as a type 2 region. Now, as you're doing the homework, you might be asked, write this as type 1 or write this as type 2. Again, I'm not concerned with that vocabulary, although I don't think it's too difficult. But what I would do if I wanted you to set things up a particular way is I would say set this up as an iterated integral, integrating with respect to x first, or integrating with respect to y first. Okay, so, all right, let's see. So if we do this, let's get our equations for those left and right boundaries. Now these are lines. I'm going to start with what's familiar to me. I'm going to get y as a function of x. So let's see. The slope here, it looks like we're going up 2 and over 2. So the slope is just 1. And so I can sort of see by inspection, if I followed it up, the y-intercept would be at 4. So I could say this is y equals x plus 4. If I wasn't sure about that, I could always use point slope form. I could say y minus 2 is equal to 1 times x plus 2. And if I simplify that, it becomes the same thing. Okay. Now, that's how I'm used to getting my lines, but I know I'm trying to describe the left boundary. So I want to solve that for x. So x is y minus 4. All right, over here, looks like this is just y equals negative x plus 4. The slope I can see is negative 1 because we're going down 2 and over 2. And again, I can pretty easily see if I just follow that line back, we'd have a y-intercept of 4. Okay. So that's going to mean that x is 4 minus y. All right, the bottom is obviously y equals 0, and the top is y equals 2. So my inside integral, I'd be going from left, which is y minus 4, to right, which is 4 minus y, f of xy dy. That's going to give me my cross-sectional area. I'm sorry, f of xy dx. Oh my goodness, that was bad. I was going from left to right. If I'm integrating left to right, that is dx. Huh. I caught myself because I actually didn't do that on purpose, but it's a great teaching moment. I caught myself because I went to say now I need to multiply by the thickness of the slice, which is going to be a change in y. So that's going to be my dy, and then I'm adding up all of the slices, which started at a y value of 0 and ended at a y value of 2.